All right, so the live stream is loading, so it should be up in about a minute. Great, thank you. All right, good afternoon, everyone. I trust that you're all keeping well. So today we'll be having our session with Gearbox on the IoT topic for the day, which is the fundamentals of IoT, where we'll be having the intro aspect to it and also diving a bit deeper for the teams that have projects that are more on the IoT side and maybe not in the AI, or the teams that are on both ends as well. So thank you very much. So I'd like to welcome Mr. Latif Cherono to be able to take it up from there. Thank you.
Thank you for the introduction, Favor, and to everybody who's joined in, welcome. This is our second training session for the Africa IoT and AI Challenge. The reason for the sessions are twofold. One, to help any of the startups with any gaps that they may have in developing their solution. That's the first part. And then the second part is also to provide some background, context, and interest in anybody else who's looking to develop an IoT or an AI-based solution. We're looking forward to this challenge being a continual annual event, and hopefully even becoming a regional event in the years to come. A little bit about Gearbox. Gearbox is a hardware incubator based here in Nairobi. We focused on helping anyone who wants to create a product, be that from ideation all the way up into something that is ready to go into the market. And this product can be mechanical, it can be electrical, it can be electromechanical. And we have the capacity and the capability to help with that. Our trainers for today are Evelyn and Patrick, and they will be going through letting you know what the fundamentals of IoT are. Yesterday, they covered machine learning and all the different facets of that. Today, they'll cover IoT, and then on Monday, they will cover how does machine learning and IoT come together, especially when you're trying to create a solution. And then tomorrow, we'll have a session on documentation, which is very important when you are creating a solution and you're looking maybe either for funding or for scaling. It's really important to have your documentation for your solution in place. So we'll have an expert around that coming in from the IEEE Society of Kenya. But let me hand over to our trainers for the day, Patrick and Evelyn, and they can just give you, let you know a little bit about themselves and then start the training. So over to you, Patrick and Evelyn. Thank you.
Okay, hello, thank you. I'm Patrick Limo from Gearbox, Kenya. I'll be taking you through the fundamentals of IoT. Before we start, I can let Eve introduce herself.
Hello, good afternoon to Evelyn Otieno from Gearbox, and I'll be taking you through the requirements to do Internet of Things. Thank you and welcome.
Okay, cool. So without wasting time, I would like us to start. So let me share my screen. First of all, I would like, because today we'll be covering the IoT fundamentals. Let me start by first of all maybe showing you my portfolio. So here is my portfolio. I hope everyone can see my screen. So here is my portfolio, even though it's not as nice as these are the kinds of projects I've done. Starting from the automatic fire extinguisher robot, garbage collector robot. We have the automated greenhouse. all the way to face mask detection, obstacle avoidance. We have making all those kinds of projects which are dealing with IoT. Okay, cool. So that's it. So let's move to today's work. So today I'll be taking you through the fundamentals of IoT, and seems I have a network issue, but let me sort it out. Whereby just a minute. Okay. Let me sort it out. Just a few minutes.
All right, as we wait for Patrick to sort out his network situation, if any of you have any questions around IoT development, just put them in the chat and we will get around to answering those at the end of the session. So please just take this time to think about any questions that you would like to ask and let us know, and we will try to give you an answer for that at the end of the session. Thank you.
Hello.
Hi, Patrick. Are you ready to go?
Yeah. I think it's now stable. So, okay. Sorry for interruption. Okay. So,
Hi, Patrick, you're on mute, please.
Maybe might it be possible for us to have maybe Evelyn to share a bit as he rejoins the session?
hello.
Yes, Patrick, are you back?
Yes. Yeah, I'm back. I think it's good now.
Great. Yeah, thanks. Go ahead.
Cool. Yeah, sorry for that. So today we'll be checking the IoT fundamentals. And the today presentation we will cover what is Internet of Things, how IoT works, the current status and the future prospects of IoT, the knowledge management that's from data, the wisdom, the future of IoT, the potential of IoT, the few applications of IoT out there. We have the application, technological challenges of IoT, criticisms and controversies of IoT. So without wasting time,
Just a
I would
moment,
like to.
Patrick.
Yes.
I think we don't see the slides. If you could just please switch to your slides tab.
Okay.
Yep.
Let
And
me
then
share.
I think we'll be good to go from there. Yeah, because we're seeing your screen, but we don't see the slides tab.
Okay, let me sort out.
Okay. No problem. Okay.
So I believe everyone can see my screen now.
Yes, we can see it, and we see yes, IoT fundamentals. Yes, thank you.
Thank you. And sorry for that also. Today we'll be covering what is Internet of Things. I'll just be doing an overview of Internet of Things. Then I will let Eve tell us how to start IoT. And then also we'll have Maxwell telling us talking more of the industrial IoT. So I won't waste time here. So I would like us to start real quick. So I'll start by what is IoT. So the IoT is the Internet of Physical Objects or things embedded with electronic software, sensors, and network connectivity, which enables these objects to collect and exchange data. Basically, it's all about adding the addable devices to Internet. Yes, and also we love so it's always the Internet of Things. Now, what is the things? Things in IoT sense can revert to a wide variety of devices, such as the hard monitoring implants, that's the biochip, transponders on farm animals, electric clamps in coastal waters, automobiles with built-in sensors, DNA analysis devices for environmental, food and pathogen monitoring, or field operation devices that assist fire extinguishers in search and rescue operations. How about the history of IoT? So remember, we are really moving in just doing it faster so that we can have even Maxwell talk also. So what is I can say the history of IoT is all about. It started with the RFID. So that's radio frequency identification. But it started back in 1999 through the Auto ID Center in MIT and the related market analysis of application. That's it. So it started with the RFID, yes. How IoT works. So Internet of Things is not the result of a single novel technology, and that's right. Instead, we have several complementary technical developments provide capabilities that taken together help to bridge the gap between the virtual and the physical world. These capabilities include communication and operations, addressability, we have the identification, we have the sensing, we have actuation, embedded information processing, we have localization, and we have the user interfaces. How IoT works. So first of all, we have the RFID there, we have the sensor, we have the smart tech, and we have the nanotech. So the RFID, so this is an example of just an example. RFID will the work is to identify and track the data of things. Sensor is to collect and process the data to detect the change in the physical status of the things. Now the smart step is to enhance the power of the network by devolving processing capabilities to different parts of the network. Now we have this nanotech, which focuses on the small, making the smaller things to have the ability to connect and interact. Cool. We have the structure of IoT. The IoT can be viewed as a gigantic network consisting of the networks of devices and computers connected through a series of intermediate technologies, where numerous technologies like the RFID wireless connection may act as enablers of this connectivity. So still in RFID, we have tracking things. That's real-time item traceability and addressability by the RFIDs. We have feeling things. Sensors act as the primary device to collect data from the environment. We have sharing things. That's nanotechnology. We have the thinking things, embedded intelligence in devices through sensors as form the network connection of to the internet. It can make the things realize the intelligent control, and we can achieve the intelligent through what you call software. Remember, in IoT, we always have the hardware and the software. So how can we make that hardware to be intelligent is through the software. The current status and the future prospects of IoT, as you can see, back in 2003, we had the connected devices was about 500 million, and the world population was 6.3 billion. Now, from 2020, that's last year, onwards, we had 50 billion connected devices, and the population around 7.6 billion. So the third quarter change is the only thing permanent in this world. Okay, we are moving to the IoT as network, as a network of network. So remember, the goal of IoT is to add the devices, that's addable devices to internet. So Internet of Things, we can see there education, business, home, health, we have water, energy, and transport. So we have the individual networks, we have the connected together, and with security analytics and management. So these networks connected with added security, analytics, and management capabilities. This will allow IoT to become even more powerful in what it can help people achieve. So this is the future of IoT. We have knowledge management. That's turning data into wisdom. So as you can see there, the more data that is created, the better understanding and the wisdom people can obtain. Remember, we need more data so that we can understand it better. As you can see, we have data, we have information, we have knowledge, we have understanding, and we have wisdom. The future of IoT. What happens when 50 billion machines become connected? The sky is not a limit. It is only the beginning. It is only the beginning with IoT. So as you can see, there will be having that's industrial internet, whereby we have fully connected of devices. So that's the future of IoT. The future of IoT is to add the addable devices to internet and fully control and have fully control over them. The potential of IoT, we have a potential of IoT in areas such as aviation, in power, in healthcare, in rail, in oil and gas industry. Unlocking the massive potential of IoT. So what will really unlock IoT is when we connect when we have that's machine learning and IoT working hand in hand, and also the network connectivity. And since we have 5G, I think they will really unlock the massive potential of IoT. Technology roadmap of IoT. Remember, it started from the RFID. That's back since 1999, all the way now that we have a lot of applications in IoT. So you can go through that the technological roadmap. That's the Internet of Things. We have the RFID tags for tracking, routing, inventory, and loss prevention. And then we came to surveillance, security, healthcare, transport, food safety, document management. Then we go to locating people and everyday objects. And now dealing with teleoperation and telepresence, ability to monitor and control distant objects. So that's the roadmap of IoT. Remember, it started back in 1999 with the RFID. We have the application of IoT. the ultimate goal of IoT is just to automate human life. So we have the few applications of IoT, like building and home automation, whereby we can have an example of Alexa, where Alexa is really doing good when it comes to home automation. Also in manufacturing industry, in medical and healthcare systems, in media, in environmental monitoring, infrastructure management, energy management, transportation, better life better quality of life for elderly. This is where we talk of the monitoring of their health, and there we talk of the adoption rate of smartwatches in Africa. As we can see that the adoption rate of smartwatches in Africa, it is still low, but we are expecting it to shoot since as the aging population grows, we need to really monitor their health. And as you know, we have two smartwatches which can really monitor their health. Okay, cool. To diverse application. So as we had checked that the application of IoT, we have building and home automation, and now narrowing down to home consumer. That we are to diverse application whereby we are narrowing down to each and every devices. Like for instance, in home consumers, we have light bulbs, security, pet feeding, irrigation controllers, smoke alarm, refrigerators, and washer, dryer, stove, energy monitoring, and all those kind. In transportation mobility, we have traffic rules, telematics, and all those. And in health also, we have the patient care, elderly monitoring, we have remote diagnosis. In building and infrastructure, we have all sorts of HV, SZ, and also we have the security, lighting, electrical, transit. In cities, we have the electrical distribution, maintenance, surveillance, and also even the waste management. And all those we have sensors of this kind. I think later on we will show you even an example of projects of IoT we did in GA Academy, yes. And also I think Maxwell will talk much more about that. Smart parking, showing us the smart parking, that's an application of IoT. That's the future. We have also efficiency of waste management in smart cities, supported by the sensing as a service, whereby we can apply the MQTT and all those devices. We control the waste management, or we control the waste management in the city. Sensors in sensors even in agriculture. We have in the world of IoT, even the cows will be connected and monitored. Sensors are implanted in the hides of cattle. This will allow farmers to monitor cows' health and track their movement, ensuring a healthier and more plentiful supply of milk and meat for people to consume. On average, each and every cow about 200 MB of information per year. Okay, you can just go through that. How much more IoT can do is only left to your imagination, because the future of IoT is really bright. And I think that's it. And IoT application scenario in shopping, that's just telling us the applications of IoT. How many steps you have worked today? That's just tracking of that's another application of IoT. Okay, how well do I how well do I sleep? That's also application of IoT. I want to know more about myself. That's more of IoT also. We can deploy this with smart watches. IoT helps you in live logging. That is it. Through a control computing, control computing, that's an application of IoT. Technical challenges of IoT. So we have challenges of IoT also. We are talking about scalability, technical standardization, interoperability. We have discovery. We have the software complexity, data volumes and interpretation, power supply, interaction and short range communication, wireless communication, fault tolerance. Big data is not magic. It doesn't matter how much data you have if you can make sense out of it. Yes, that's it. We have also controversies of IoT. That is privacy, security, autonomy and control, social control, political manipulation, design, environmental impact, influence, human moral decision. That's controversies. Thank you. So I've just finished my first slides on taking you through the overview of IoT. Yes. So I think what we'll move next is now seeing on how we can really do the IoT, even can do the IoT application projects. So I will let Eve check us through on how to start doing IoT. Then later on, we'll now come and check the hardware age of IoT. And later on, we'll have Maxwell taking us through industrial IoT. So this was just a real quick overview of IoT, and I hope everything is okay. So if So, if take us through.
Good afternoon, everyone. I hope you can hear me, and I'll just kickstart immediately. I'm going to share my screen as I take you through the requirements to do IoT. Hope everyone can see my screen. And the requirements to do IoT, we have Arduino Kit, Arduino app, embedded C language, Raspberry Pi, and Python. And to begin, Arduino is an open source electronic platform that is based on easy to use hardware and software. And on the other hand, the Arduino Kit consists of all the components used for building digital or electronic devices. The Arduino Kit actually physically in it has all the components that are used in building a device, any digital or electronic device. So Arduino is designed to make the process of using electronics multidisciplinary projects more accessible. And Arduino can sense the environment by receiving input from a variety of sensors. It can also affect its surroundings by controlling lights, motors, and other actuators. And from how Patrick has taken us through, I think to that point we've understood what sensors are, how they are used, applied in IoT. So if I have to give a brief history of Arduino,
So hello.
Hello, Patrick.
Sorry, there was some network issues on my side. Can you hear me?
Yes, yes.
Yes, you can hear.
Sorry about that. I'm really sorry about that. So let me just share my screen again. And can you see my screen?
Yes.
I was on the brief history of Arduino. It was developed in 2005. And the founders are Massimo Banzi, Arduino over Ivrea, and began producing boards in a small factory located in Ivrea. So this is a sample of Arduino Kit. And inside there, I know it is not really that clear to some of us, but inside you can see a USB cable. There's an Arduino Uno. And Arduino Kit, we have the following. These are just a few, but there are a number of them. So I just picked the first 8 components, but of course there are many. It's not only the 8 that I've mentioned here. So we have Arduino Uno, and with Arduino Uno, it is the most important piece in it. Like there's nothing you can do without Arduino Uno. Then we have breadboard. The breadboard is used to experiment with circuits without need for soldering wires. Like as long as you have the breadboard, you don't have the soldering wires in experimenting with circuits. Then we have LEDs. And as you know, there are various types of LEDs. There is red, yellow, green, and even white. So in that Arduino kit, we have LEDs of different colors. Then we have USB cable. The USB cable can be used to just the normal use of USB cable. It can be used to connect your Arduino and PC, or even any source of power supply. Then we have a 40 times pin head. It is a series of 40 pins that are inside the Arduino kit. I'll challenge us to go do more research on that so that you see a photo of how the 40 times pin head looks like. Then we have the ceramic capacitor. We have H-bridge. We have accelerometer, among others. We can do a research on that to understand more about the components in the Arduino kit. Then in the programming environment, the Arduino Uno can be programmed with the Arduino software. The Arduino software, which is IDE, Integrated Development Environment. Arduino IDE works on both Windows, which means it works across all platforms like Windows, Linux, Mac platforms. And then here is a photo of Arduino IDE, how it looks like. Up there, we have a menu bar that a long file, edit, sketch, that is the menu bar. Then immediately after the menu bar, we have, I'm sure you can see my screen. This first icon here, it's for verifying. And then the next one is for uploading. The next one here is for new, when you want to open a new project, that is. Then we have an icon there for opening. And then we have the last one, this is for saving. Then when you look down there, here, if you're able to see, I'm pointing, this is a Arduino type and port that I'm currently using. So you can see I'm using UTF-8, and then there is no board selected, which means I never selected the board. So while choosing Arduino port, you have to check from your device, from your computer, from the device manager. Choose a port that is same as that is actually the same port that is on your computer while choosing from the Arduino IDE. And then advantages of Arduino, it is open source. It is simplified and user-friendly, especially for beginners. For the people who want to start the walk to IoT, it's advised to use Arduino because even for the kit, as long as you have the IDE environment and then you connect the USB to the kit. So it is simple and easier to use. It is portable, which means I can program in my computer using Windows OS, and then I can transfer it to Linux, and still I'll be able to run it from Windows to Linux. It is inexpensive, that is in terms of price and cost. Then lower consumption power. Then no additional programmer or burner hardware required for programming board. This is a Arduino board. Like initially, we talked about the components found in Arduino Kit, and the most basic one, the most important one rather, is always the Arduino board. And here is a sample of how Arduino board looks like. And the most popular Arduino boards that we have Arduino Uno, which we've checked in the previous slides. It is the most basic used one lately. And then we have Arduino Leonardo, we have Arduino Mega, Arduino Duo, Arduino Micro, Lilipad, and Yarn. So again, here I'll challenge us to read more on the boards and how they work. Of course, we are going to share the slides as well. Then the next requirement for the Arduino requirement under IoT, it's mostly used by novice, like beginners, those who are starting the walk to IoT, you know. But now for the advanced, for people who have advanced, we can use Raspberry Pi. And here is how a Raspberry Pi looks like. Actually, physically, it's a very small item. And a Raspberry Pi is a fully featured microcomputer squashed onto a circuit board, measuring approximately 9 centimeters by 5.5 centimeters. I told you it's not a big gadget. It is not a size of a computer. It is so small. So it was founded by Raspberry Pi Foundation, a charitable organization. The features of Raspberry Pi, it is, the cost is so low, ultra low cost, and ultra low power, that is 1 watt. It is credit card sized, fanless, instant startup, complete, easy to program computer. It provides a fun environment for experimenting with electronics and programming. So basically, it can be plugged in your TV and a keyboard. You can plug Raspberry Pi on your TV and a keyboard, and it can be used for in many ways that your average desktop anything your average desktop can do. For example, from spreadsheets to games to processing. But as we said, is for tech savvy people as compared to Arduino. The operating systems used on Raspberry Pi, we have Fedora, Debian, Raspbian, Arch Linux, ARM. Like for people who've done Linux, at some point we used Raspberry Pi. Then programming by default, supporting Python as the educational language. What do I mean? While using Raspberry Pi, the language that you can use is normally Python. And yesterday, it is the default language that is. And yesterday we went through Python and we were able to learn the basics of Python. Then any language which will compile for ARM version 6 can be used with the Raspberry Pi. Then we have applications of Raspberry Pi. It can be used for making supercomputers. Then there's also Raspberry Pi medical device input shield. We have voice activated coffee machine. Then lastly, it can make your old TV into a smart TV. That is, you can play videos, 3D games, music when you connect Raspberry Pi to your old TV. So it comes with those features. And you can also connect a monitor, keyboard, and mouse and use it as a normal computer. But now it also has disadvantages. The fact that it does not have a hard disk that is for permanent storage. It normally uses SD card. So we don't have, it doesn't have a permanent hard disk storage. Then another disadvantage is the fact that RAM is not removable or swappable. Then another requirement for IoT development, we have embedded C language. And with embedded, we use Arduino App ID and an embedded language. But embedded C language is just an extension of C programming language. And up to that point, I would like to invite Maxwell to take over and take us through the next session. Thank you.
Hello. So before Maxwell comes in, Maxwell will take us through the industrial IoT. Before Maxwell, I would like us to check on the hardware edge of IoT. Then we check on sample of connect or wiring. Then I invite Maxwell. So allow me to share my screen. Then thank you, Evelyn. It's really nice. So we have the hardware edge as the board which are used in IoT. We have Arduino, and Evelyn, you have just check us through this. We have the first one is Arduino, it's for beginners. Then we move on to Arduino Killer. That is the ESP8266. The reason it is called Arduino Killer is because it has Wi-Fi. So it is cheap compared to Arduino. Since Arduino, when you have to buy Arduino and you buy also the Ethernet shield. Okay, cool. So we have the ESP8266, which is called Arduino Killer. You can connect to Wi-Fi direct. You also have the Raspberry Pi. It's also thank you, Eve. Eve has taken us through through the Raspberry Pi. Then we also have another one called the Beaglebone. It's more powerful compared to Raspberry Pi. Then also we have another one called CC3200. Yes, that is it. So, and also we have the breadboard. Remember, when you are doing prototyping, you have to have breadboard. You have the board. For our case, you can use Arduino. You can use Raspberry Pi. So if you have your own board, that is the Arduino or the Raspberry Pi or the ESP8266 with the breadboard for connection and also a sensor. So you may need the breadboard as for prototyping and a sensor, a sample sensor. This is the DHT11. Here we are. You can see the wiring of the embedded systems. Yeah, and that is it. So I would like to welcome Maxwell to take us through the industrial IoT. So just so Maxwell, I hope you can hear me, Maxwell.
Yes, Patrick, I can hear you.
Okay, so let me share the screen so that you can do a presentation for us. Just a moment. So as I share, Maxwell.
Yes,
Hello,
Patrick.
Maxwell.
Yes, Patrick.
Yeah. So as I share, I have a question for you. Yeah, it's just a very funny question. Yeah. So yeah. So yeah, I can share now. Do we have a can we have an IoT system that is offline?
Yeah, that's actually possible, and maybe I'm going to talk about that in a few. Yeah.
Okay, fine. So I think just go on.
Sure. So hi guys, my name is Maxwell Washira, and I am an IoT enthusiast. And yeah, not to brag, but I can say that I can do a complete IoT project from the hardware design, that is the PCB, to web backend and machine learning. So yeah, welcome. So we are starting on the different IoT technologies. So to the next slide, I am going to talk about the IoT problems and constraint. Patrick had mentioned this before, but probably, this time round, I'm going to talk about these constraints and how you're going to choose the relevant IoT technology for your product or project. So first thing first is energy consumption. And when it comes to energy consumption, this will apply to devices which are powered by battery. So if you are intending to build an IoT product that is powered by a battery, you really need to see how the IoT device consumes energy, because there are certain technologies which are not battery friendly. And if you try and do power your device by a battery, you will have to keep on changing the battery in probably 6 hours if it's streaming continuously. And yeah, the other thing is connectivity, cost. Something that I think I will talk about is the payload size. And by payload size, I mean the size of the data to be transmitted. So yeah, size of data. So like, it's just like music files, whatever it is. Any file occupies a given space. It can be 1 MB, it can be 1 kilobyte, it can be 12 byte, and so on and so on. So there are certain IoT technologies that are able to transmit only a maximum of 12 bytes, while others are capable of transmitting, let's say, limitless. The uplink and downlink payload doesn't really matter, but yeah, we are going just to see that probably in the next slide. So yeah, these are the different IoT technologies that are there in the market. And probably if you want to develop an IoT product, you might come across all these IoT technologies. And yeah, you need to choose one depending on certain parameters. So we have the GSM, Wi-Fi, BLE. We are going to discuss each and every of these technologies in the coming slides. So we can go to the next slide. So we are going to start with Wi-Fi. I think Patrick and Evelyn had mentioned something to do with Wi-Fi. So if you want to use Wi-Fi for connectivity, yeah, we will use the expressive boards. I think you've heard them mentioned, ESP, ESP32, ESP86. So ESP, it's a company called Expressive. So ESP is a short form actually of expressive. And in the right, you can see the architecture of Wi-Fi. So you have your MCU, it connects to a router, and then it's able to send data to, let's say, your mobile application, web app, and so on and so on. So you can either decide to choose Wi-Fi as the primary architecture. So in the next slide, we are going to see another architecture. So you can decide to communicate over GSM, GPRS. So GSM, GPRS, this is the same technology that our mobile phones use. So when it comes to cellular connection, the moment you turn your cellular connection on, you can be able to access the internet. So it's actually the same thing, actually the same module that we use in our IoT projects. Remember when I said that one of the constraints of choosing an IoT technology or architecture is power consumption. So the GSM GPRS, it is not power friendly at all. So if you decide to power your project with a battery, definitely this is not the way to go. But the advantage of this is that, yeah, it is one of the most reliable, meaning that it can work where there is no Wi-Fi, and you really don't have to have any other infrastructure put in place for it to work. You just need to power it, and yeah, it's going to transmit. So probably the problem with Wi-Fi, the initial architecture is that, yeah, you need a Wi-Fi router for it to work. But with the GSM GPRS, you only need some SIM card, and the SIM card needs to have, let's say, bundles, and it will be good to go. Yeah, its architecture is a little bit complicated, and it's more of telecommunication engineering. So let me not touch on it, but those who are interested, probably you can ask questions about it, and I'll be glad to explain. But the GSM, it's not power friendly at all. So if you're powering the device with a battery, don't think about it. So we can go to the next slide. Yeah, we have the Bluetooth Low Energy, BLE. So yeah, you can have an app that communicates with your IoT hardware through Bluetooth. And yeah, I think this is common. You've seen us send files. I think before these applications for sending files became popular, we used to send files via Bluetooth. I think you can remember sometime back, we shared audio files with Bluetooth and so on and so on. So it's actually the same thing. So here, but this time round, maybe you're sending data or receiving data using the Bluetooth technology. And to be specific, it's the BLE, Bluetooth Low Energy, meaning that it is power friendly. So the problem with Bluetooth again is that it has a small range, and that is 0 to 100 meters maximum. Yeah, so if you want to transmit data beyond 100 meters, definitely this is not like the best choice for your project or product. Yeah, we can go probably to the next slide. Yeah, I think, Patrick mentioned that this is the oldest of the IoT. It's the pioneer of IoT. And yeah, this is RFID, which is basically radio frequency identification. And yeah, I think one way or another, we've all like used these technologies where you have like a card, and for you to access maybe a certain room, you just need to maybe go and scan your card on the RFID reader, and then you are either allowed to go or you are denied access. So this is another type of radio frequency. Another type of IoT technologies, and it uses, it's among those active 2.54. And you can see basically that's the architecture. So we usually have an RFID reader and RFID tags. So the RFID reader reads the tag, and then we kind of have like a database where you have stored which tags are allowed to have certain access and which tags are not allowed. and still using the application, you can be able to add new cards into the system, delete some other cards out of the system, and so on and so on. So basically, this is also an IoT system, and it's based on radio frequency. Yeah, and it's mostly used for access control. So over here we have, I can say, one of the emerging technologies, and it's called LoRa. LoRa stands for long range. Yeah, it's like long range put together to form one word, which is LoRa. And yeah, it's long range, and I think it's one of the most battery friendly technologies that you will find out there. So yeah, it's battery friendly, but that comes at a cost. You remember me mentioning that another constraint is the payload size, the size of the data to be transmitted. So it can only like send a maximum of 12 bytes in one message. So you can only send 12 bytes in one message. But yeah, it's very, very, very power friendly. Yeah, you can, yeah, if you're powering it with a battery, be sure it will last even probably for, let's say, 6 months to 1 year, depending on how good your battery. So it's very battery friendly, but that comes at the cost of sending only 12 bytes. And then, yeah, this is the architecture over here. So it uses radio frequency. And yeah, you will have your radio modules. You can see on the right, that is a LoRa radio module. And then actually we call them the end nodes. So these radio modules are what are known as end nodes. And then these radio modules, you need something called a gateway. So you can either buy a gateway or use a Raspberry Pi to make a gateway. So you have a LoRa node or an end node, which is a radio module, and it sends data to a gateway, which is something like a Raspberry Pi. And then after you're sending it to your gateway, the gateway now forwards it to a network server. So let me just again explain the architecture. You have your radio module, and then yeah, they are long range radio modules. So depending on the radius, we have gateways which can scan up to 65 kilometers radius. So if you have a gateway which can work in 65 squared kilometer radius, yeah, you can send data from your end node within that radius to your gateway. And then the gateway forwards it to a network server, and the network server is known as the TTN. TTN stands for the Things Network. And then from the Things Network, that is when you can now like rechannel your data to your application server. So we have the network server and application server. It's actually, I think for me, I can say I think it's the cheap. It's the cheapest if you're doing IoT in bulk, because yeah, you don't like have to worry about paying a third party. You only need to acquire the end nodes, the radio modules, and then maybe you need to acquire a gateway. Other than that, every other thing, sending data and stuff, it's all free. So you won't have to pay a shilling. So that's the LoRa. Maybe we can go to the next technology. So the other technology, which is almost the same with LoRa, is the Sigfox. So we have the Sigfox network. Again, it can only transmit 12 bytes. So that means it's also power friendly. So you can also use battery to power such a product that will use the Sigfox architecture. So the difference actually between Sigfox and LoRa is that for LoRa, you have to make your own custom gateways. So it depends with your custom gateways. So if there's no gateway around, you will be forced to make one. But when it comes to Sigfox, they're actually responsible for the, let me say, gateways. They have base stations. So they actually have base station. And in this case, let me talk about Kenya. So for Kenya, Sigfox has partnered with Liquid Telecom, and wherever there is Liquid Telecom, internet, you can also find the base station for Sigfox. So where you can access Liquid Telecom, you can also access Sigfox. So they have base station all around, so you don't have like to worry about the gateways as it was the case with LoRa. And yeah, they again have like a Sigfox backend where data will be sent to that backend. So yeah, the difference is that you don't have to worry about a gateway because they have a base station, and they also have a backend where you can just see the data coming in. So that again comes at an expense. So for the LoRa architecture, you won't pay anything apart from getting the hardwares. But for Sigfox, you will be charged a particular price at the end of the day. Sorry about that. Yeah, so yeah, I think that's clear between Sigfox and LoRa. You can have your questions and I will respond them later on. So we can go to the next slide. So the next slide is more on NB-IoT. So NB stands for Narrowband IoT. You remember me talking about GSM, and I said GSM is not power friendly. Yeah, definitely. Even I think we've all experienced that. Probably if you're using your mobile phone and you turn your cellular data on, there is the power consumption rate is usually high as compared to if you're not, if your cellular data is not on. Basically, that is because the GSM is power hungry. We say it's power hungry. So to overcome that, this is also built on top of the GSM architecture, but the normal GSM is meant for mobile phones, but NB-IoT is GSM, which is particularly meant for embedded device, which is particularly meant for IoT. So NB-IoT, it is more power friendly as compared to the GSM. And another advantage is that you can use it anywhere, just like the GSM. For as long as you have your SIM card with it, and the SIM card has data loaded in it. So you can use it anywhere. It's more power friendly as compared to the GSM, but yeah, it works the same as the GSM. So it's like a GSM built for IoT products. Yeah, we can go probably to the next slide. Yeah, there's another technology that I hadn't mentioned, and definitely that is the Ethernet. The Ethernet, I think you were shown what the Raspberry Pi is, and yeah, you're actually going to see that. So again, these are some of the projects that we've done. So these are like PCB designs for IoT products. So if you want like to build an IoT product, the first thing, of course, is to identify the IoT technology you're going to use. So for instance, this one, we are using LoRa, and we are using this specific radio module, which is RA02. So this is a PCB that I designed, and it uses the LoRa module, and yeah, it will send data again to a gateway, and then from the gateway to the network server, which is called the TTN, and then from there to our custom application server. So maybe we can go to the next slide. Yeah, this again is another IoT PCB. Yeah, this one uses Raspberry Pi. And yeah, to be specific, we call it the Pi Compute. Pi Compute is much more tinier than the normal Raspberry Pi. You can see we have the Pi Compute there at the center. And of course, the Pi uses Ethernet for connection, and it also has Wi-Fi. So you can see we have like the Ethernet port over there. So yeah, you can use the Pi Compute and the Ethernet or the Wi-Fi technology to connect your device to internet. So we can see the last slide. So you can see again this one. I have like two IoT technologies like put in together. So this one I have both the LoRa. I have both LoRa radio. You can see we have the RA02 as well as the ESP for the Wi-Fi. So again, you can combine more than one IoT technology for as long as it will suit your custom needs. So again, you have to identify the technology to use, and yeah, you get to see the pros and cons of each technology before you kind of like decide, I need to use this technology. So I think with that, that brings the end of my presentation, and yeah, probably we'll take it back to you, Latif, and yeah, if there are questions, we are willing to answer.
Okay, hello.
Hello.
Great, thank you. Hello, so Patrick, Evelyn, and Max, thank you very much for that really in-depth explanation on IoT, all the way from what IoT is and to how you can use IoT in your solution. So I'd just like to ask a couple of questions, and this one is directed to Max. What does it look like from a Kenyan standpoint as far as the different communication protocols that we have for IoT? I think you mentioned a little bit about Sigfox, but if you could just go through and just say what is available, that would be, I think, quite helpful. Thank you.
Okay, Latif. Almost all technologies are available, and most of them, they will need you to have, let's say, a couple of developers, maybe the PCB developer, the network infrastructure developer, and so on. So if you're probably a startup and you do not have like, let's say, the financial resources to hire all those kinds of engineers, I think I'd personally recommend you go for Sigfox, because I can say Sigfox is like plug-in ready. All you need is to like get the Sigfox whistle, and you don't like really need to worry what happens in between. Once you get the Sigfox whistle, you will get your data in the Sigfox backend. But again, you can decide to go for the other IoT technologies. There is the GSM, we have the Wi-Fi. I heard that Safaricom is partnering to have NB IoT, like SIM cards and all those kinds of stuff. So personally, you can access almost all these technologies, but at an expense. The development time will be, you'll spend a lot of time in development, as well as financial wise in paying all those kinds of engineers, but Sigfox is plug-in ready. So yeah, all those technologies that I mentioned, Wi-Fi, GSM, LoRa, RFID, they're all available. But yeah, I think, I don't know if I'm clear enough. So they are all available, but Sigfox is plug-in ready. You don't have to worry about a lot of things.
Great, thank you for that. The next question is, I think you didn't mention MQTTP today. Maybe you could just talk a little bit about that and how you can use that to make your IoT solution more energy efficient in transmission.
Oh, okay. Thank you, Latif. Mostly we talked. Mostly we talked about the hardware infrastructure. We didn't mention about the software infrastructure. So when it comes to software infrastructure, I can say we have two common types of software infrastructure when it comes to IoT devices. We have the HTTP and we have the MQTT. So HTTP, even if you go to your web browser right now, you will see like almost all the links, they start with HTTP. So HTTP actually was not meant for devices. Therefore, it's kind of heavy when it comes to our devices. So it's not the preferred network, because first of all, it's heavy, and it will also result to a lot of power consumption, since a lot of our processor is going to be used trying to process the HTTP request and all that. So for that reason, there is this other software architecture, which is called the MQTT. And yeah, the MQTT is like specifically meant for IoT devices. Yeah, and it's free and open source. Yeah, it has a broker, it has a server. Yeah, it has a lot of things. Probably we are going to talk about it on the last day when we are trying to integrate IoT and AI together to form like one huge product. But yeah, I'd recommend MQTT because it's lightweight, and as a result, you won't need much processing power. And yeah, that will also affect the performance of our battery. For HTTP, it is not lightweight. It's meant to be used by computers and browsers, so it's kind of heavy. I think I have just mentioned the basic stuff, just like to differentiate the two, the HTTP protocol and the MQTT protocol. Yeah.
Great, thank you, Max. That was a great question. This question I think I'll direct to Evelyn. When you're trying to decide on the hardware that you want to use to either test your product or start working on your solution with, what would be the path to select? So let's say you're just starting out and you're trying to decide whether you should go between an Arduino board or you should go for a ESS. What is the best way for somebody who's just starting out to make a good choice on the hardware to develop their solution?
Okay, choosing the best for the IoT development. For the beginners, I'll recommend Arduino because it's simple and easier to use for people who are just starting the journey to IoT, as compared to when you want to use a Raspberry Pi, which is more complex. So in this case, Arduino is the best because for novice beginners, because it also has that kit. The kit has all the components. Someone has just raised the hand. Okay, for Arduino, it has the kit, and the kit has got all the components for development. Like when you get the kit, the interaction is, directly, physically, such that you can differentiate what Arduino Uno is, the USB cable, such like things, when compared to Raspberry Pi. And also, when you look at the IDE environment, it is simple also to use compared to Raspberry Pi, where you have to learn Python first. So for people who want to go this direction and perhaps they don't know anything about Python, but has some knowledge in C programming, we can go for C embedded, because C embedded is just an extension of C. So combining C embedded, Arduino environment, I think it is the best path. Thank you.
Thank you, Evelyn, for that. We have a question from Invisible J. I like that name. Yeah. So please go ahead and unmute yourself and then ask your question. Thank you.
Okay, can you hear me? Yes.
Yes, loud and clear.
Okay, I just wanted to expound on what Evelyn was talking about. I joined the meeting a little bit late. Myself, I'm an embedded engineer. You had asked the question of which way to go if you want to choose the right platform. I would also want to add that sometimes you might want to choose the platform depending on the solution you want to build. For instance, you can't be a novice, you can't be an amateur, just as she was mentioning, but you want to build something that you need it compact. You need a small solution, like a compact one. You might want to use a different microcontroller than the Arduino. So I just wanted to add that we don't want to look at the choice of the microcontroller in terms of a beginner and an expert, but we might want to look at it as really what do you want to produce, because you might want to produce something that needs a different board, but it's not necessarily because you are a beginner you'll go for Arduino, but it depends on really the solution you want to put out. Thank you.
Thank you, Jay. That's actually a very good point, and I do appreciate that view. Thank you. Does anybody else have another question to ask, please?
Maybe I'd like to again clarify on something. So when we are talking about IoT technologies to use, I think by that we mean the GSM, the Wi-Fi, all those like architectures that we talked. So I think we will like really need again to differentiate between embedded systems and IoT. So an embedded system is a part of an IoT system, because like an embedded system, this is where you have your microcontroller, you have the sensors and all that of stuff. But when it comes to the IoT part, we are actually, I think, mostly talking about the connectivity aspect. How is it connecting to the internet or to any other particular network? So yeah, an embedded system, that is where you have like your sensors, microcontrollers, other input-output devices. But when we talk about like the IoT technology, that is like, yeah, the connectivity aspect. How is it connecting to your network and other things? So maybe that is for Arduino, probably Arduino it's alone, it's not like an IoT, we can't say it's an IoT technology or something. It's more of like an embedded system thing, because it's a development board with a microcontroller which has GPIO. You can attach your input-output devices. So an Arduino alone, it cannot like send data to the internet. You have to interface it probably with a GSM module, a Bluetooth module. So now that's where the IoT comes in. So I don't know if I'm clear, if I'm making sense. Yeah.
Yes, thank you, Max. That's very clear, and thank you for that clarification. So for the last question, I'd like to ask, and I'd like you to start, and maybe I'll add something to the end. So when you're a startup and you've used a development board, or you've used an IoT board, and you decide that it's at this point that you want to create your own solution. So maybe if you could just talk about why you would want to create your own solution, that is design your own PCB, and what would be the benefits of that. And this goes out to anyone who's on the call to answer. So yeah, why would you design your own PCB versus using something off the shelf? And this can go to Max or Jay or anybody who would like to answer that one.
Can you hear me? One of the advantages, I think, that one might choose to design their own PCB, and like going forward, it's already there. You will make it unique, specific to your particular function. For instance, if you go, because one of the things that one must put into consideration when talking about IoT is power consumption, and some things that that might make your solution consume a lot of power is the computation and the gadgets that are attached to it. Therefore, if you are producing a specific gadget that is, if you are doing an IoT solution that is that it's meant to perform a specific thing, if you go out there and buy an already developed solution to use for your gadget, you'll find that this gadget has a lot of things that you don't really need for your particular solution. Therefore, using it implies that you're going to use a lot of power, and you are going to use a lot of other resources that you don't need. But if you design your own, it's unique to what you're supposed to do, which means you are going to enhance performance because it will be performing exactly what you need, and yes, it will, like in short, it will improve on the efficiency and performance if you are designing your own, unlike doing what's already there. That is one of the advantages. I think if that might make one decide design their own and like using what's already there. Thank you.
Great, thank you. Thank you very much, Jay, for that answer. I think Favor, you have a response to this?
No, I actually had a question. There's something that Max had mentioned, and I think Patrick also alluded to. That's a Sigfox network. And I believe their local partner in Kenya/East Africa is Liquid Telecom. But I was wondering, what's the procedure like to engage with them for a Sigfox network use case? Because like you said, Sigfox has low memory transfer capabilities based on the fact that it's not like, your traditional GSM, which works great because a lot of the times data transfer between IoT devices that are not on the heavier end, like you talk of, say, IoT in cases of like smart screens, etc. A lot of the times it's just simple data transfers in terms of performance or metrics, etc. So in that case, what's the process like to implement or like to engage or integrate with Sigfox? That was my question. Yeah, thank you.
Okay, Max or Patrick, would you like to answer that part, please?
Sure. I think I'll answer that. So yeah, I'll get back to Favor's question in a minute. So maybe to add on what Jay said, apart from performance, having a custom PCB will also reduce the size. It will make your product more compact. Yeah, so, and generally reducing the overall cost of the system, because yeah, PCBs, I can say at the end, they'll be much cheaper as compared to using all those different modules together. So PCBs is actually the way after like doing 1 or 2 prototypes and you're sure they will work. So for Favor's question, so concerning like how do you get the Sigfox probably whistles and how do you go about it like deploying, if I think I got you right. So Sigfox, they have a Sigfox backend. So I think, I'm not sure about the URL, but I think it's backend.sigfox.com. So they have a Sigfox backend. So the moment like you get, let me say the Sigfox whistle, which is basically a Sigfox radio module, it usually has like a unique number to identify that particular radio module. So all you need is that particular number. And I said it's more of like a plugin. So like, yeah, it comes at an expense. I think the last time I checked, I am not sure about the prices. So the last time I checked, onboarding a device is about 600 Kenya shillings. I am not sure. I think that is something you need to check because that was the last time I took a look at that. So onboarding a device is like 600. So once you go through all that process of like doing the payments and stuff, you're just going to add that unique ID of the radio module, and yeah, you're good to go. It's now ready to start transmitting data to your particular account for Sigfox backend. So you need to get the radio module and probably have it collect temperature, whatever data you want it to collect, and then get to onboard the device by paying a particular fee for that device. And then, yeah, you will receive the data in Sigfox backend.
Right, thank you, that makes sense. Then is there a running cost, like a subscription fee, or is it just the 600 setup fee, the 600 Kenya shillings, or whatever it's increased to now?
The fee, I think it's per year. I think it's a subscription, an annual subscription per device.
Okay.
So at
Makes
the end
sense.
of the day, it's cheaper than GSM, because GSM you'll have to load probably data bundles worth 10,000 for the entire year, let's say. Yeah.
It's true. It's true. Thank you.
Great. So we are coming up to the end of our time. Thank you very much to Max, Patrick, and to Evelyn for giving us a very good explanation on IoT. And we're looking forward to the last two sessions, which tomorrow we'll be covering documentation on an IoT solution, an AI solution. And then on Monday, Patrick, Max, and Evelyn will be back to talk about how do you integrate an IoT solution or IoT hardware with machine learning and AI to create a system that will be able to give you value. I'd just like to add on the last question that I asked about why would you design your own PCB? Now, this I think is very important for where we are on the continent in Kenya. We need to start creating our own solutions. We need to create devices and products and services that we own the IP to. And you will do this by generating or building your own PCB, building your own system. Because then as you own this and you are the owner of your own value, you are then able to leverage it as you scale across the continent. So it's something that we have to really think about and really build that capability because we can do it. And there's no better time to do it than now. Kenya is at the forefront of IoT communications, implementing that, as Max mentioned, with NB-IoT, Sigfox, and LoRa. So if these networks are being put in place, let's go ahead and take advantage by creating the solutions that will leverage that into making products. Another thing for the startups to realize is that you can make a good living out of doing this by identifying a problem that exists within our everyday lives, and then finding or creating a smart solution around it. There are already close to 70 companies in the country that are doing this. So you can make a good living out of this. So, but you have to put in the work and go through the process of product development to understand how your product will add value to your end user. But you can definitely have a very good career out of this. And with that, I'll hand over to Favor to close us out for the day. And I look forward to seeing you tomorrow at the same time. Thank you.
All right. Thank you very much, Mr. Latif, and also to Maxwell, Patrick, and Evelyn, and also Invincible J. I'm guessing, is that Ken? Is Invincible J Ken?
J. Invincible J.
Sorry?
Invincible J.
Okay. All right. Thank you, Invincible J. So appreciate it very much. So thank you very much. I will look forward to the next session, and you can also access the session on YouTube as well. And please feel free to also email us at Kenya IoT AI Challenge, so in case you have any questions as well. And it'll also be in the video description on YouTube as well. So thank you very much, and look forward to seeing you next time. Thank you.
All right, thanks. Take care, everyone.